Hi, I am Arib. You are watching my YouTube channel. Cooling fan. When the transformers operate continuously, as a result the core, coil, main tank and the transformer oil heats up to a high temperature which can affect the operation, maintenance and output voltage of the transformer. In grid station transformer air kept cool through three different processes. It stands for oil natural air natural. In this method fans are off and the transformer is cooled by natural air. Same is the case of oil which circulates by spontaneous motion of hot and cold oil. It stands for oil natural air forced. This method is applied under a bit higher temperature. Oil circulation takes place by itself while the air is provided by radiator fan. It stands for oil forced air forced. This method is applied under highest temperatures. Fans are on that provides more air and the circulation of oil is also speed up by oil circulation pump. Tap changer. Tap changers are devices that regulate the transformer's output voltage as it responds accordingly to the varying input voltage and load by adjusting the number of turns in one winding. This adjustment, therefore, changes the turn ratio. During offloading conditions, the output voltage increases, whereas during loaded conditions, the output voltage decreases. Tap changers are typically connected in the HV winding to make fine voltage regulations and minimize core losses of the transformer. The current is also lower in the HV winding, which minimizes the risk of sparking and igniting the transformer oil. There are two types of tap changers. On-load tap changers are designed to tap the voltage without disrupting the current flow to the load, whereas off-load tap changers require disconnecting the load of the transformer before operating. Silica gel. Most of the power generation companies use silica gel breathers fitted to the conservator of oil-filled transformers. The purpose of these silica gel breathers is to absorb the moisture in the air sucked in by the transformer during the breathing process. The breather delivers moisture-free air to the conservator by passing air through a small bed of silica gel inside a cylindrical container. The silica gel acts as an air filter that strips and controls the moisture level inside the conservator and the main tank. The breather is connected by a pipeline to the conservator. Moisture can degrade the insulating properties of the transformer oil or may even lead to internal faults. Therefore, it is necessary to remove the moisture. Oil temperature indicator. This indicator detects the temperature of transformer oil. If the transformer oil gets heated to such a temperature that can harm transformer, the oil temperature indicator operates. It has two settings. First is alarm and the other is tripping. Winding temperature indicator. This indicator supervises winding temperature like oil temperature indicator. It also have two settings. One is alarm and the other is tripping the transformer. PRV/PRD. Pressure relief device are a transformer's last defense should a serious electrical fault within the transformer occur, as PRDs are designed to relieve pressure within the transformer tank. They are not relevant for transformers with no tank. During a large electrical fault, a high-temperature arc will be created and this arc will cause decomposition and evaporation of the surrounding insulating liquid. This sudden increase in volume within the transformer tank will also create a sudden increase in tank pressure. The pressure must be relieved to prevent a potential tank rupture. Wheels. Transformer has small wheels upon which it can be rolled from one place to another. As they hold the transformer at a higher from the ground or foundation, so air flow is possible beneath transformer. Buckles relay. The buckles relay is a device installed along the pipeline connecting the conservator and the main tank. It detects faults in the transformer by sensing the emitted gases to activate the trip and alarm circuits. Once the trip circuit is activated, the circuit breaker will then disrupt the current flow to the primary winding. Emitted gases are generated by the heat released induced by faults.